Alright, today we are going to do solving word problems in three variables using matrices. So real quick, we're going to start out just kind of recapping how to set up the matrix system here. So remember, you put out your coefficients of your variables, make sure they are in the same order right there. So it'll be 4, 1, negative 2, and 4. Next is going to be our variable matrix, so that'll be x and y there. And then the last piece will be the constant matrix, so that'll be 15 and 7 right there. So that is setting that up there, and we're just going to do the setup for these, and then we'll actually solve the word problems here in a moment. Remember, if you're missing something, if you're missing a piece, you need to put 0 in for it. So this first equation, we don't actually have a y, so we're going to do 7 and then 0 for y. And then this next one's negative 3 and then 8. Your variable matrix will be, I guess, x and y. And then equals your constant matrix, which is the 12 and the 2. So nice and easy there. That's all you needed to do. Sometimes they might give you a system based off of this matrix here. Notice they don't have the variable matrix. I think it's kind of implied to be there. Maybe this is a different notation. But anyways, regardless, we need three variables. They didn't give us any, so I guess we'll use x, y, and z. And then we'll go and write this as 6x plus 4y minus 2z. Make that look a little bit better. And then equals 17. And then we'll go 1x, or you can just put x, minus 5y, and then plus 2z equals negative 10. And then you can put 0x, you don't need to, so then I'm just going to write 3y minus 1z, or you can just put minus z and then equals 0. Let me make that look a little bit better. And that is it there. Okay. Next thing here is we're going to work on the setup, and then we're going to use matrices to solve all of these here. So let's see here. We got the perimeter of a triangle is 83 inches. The longest side is 3 times the length of the shortest side here. And there's kind of the second part here. I'm going to highlight it in a different color here. And the longest side is 17 inches more than 1/2 the sum of the other two sides there. So that's a little wordy there. Now, actually, the very first sentence here is actually telling us another equation. So you have three variables. We don't know what the side lengths are, so we can call them x, y, and z right there. And we know that the perimeter is 83, so we know if we do x plus y plus z, whatever they are, that should equal 83. So that'll be your first equation right there. Now the second one is going to be dealing with the longest side. And I guess I'll do this here in red. The longest side is 3 times the length of the shortest side. So I guess we need to define what side's the longest, so we'll call x the longest side. So x, the longest side, equals 3 times the length of the shortest side. So I guess we'll call z. We can, let's do like x, y, and z, and like we'll call z the shortest side. So I guess y will be the medium. Come on, there we go. So going back to that, the longest side is 3 times the length of the shortest side. So if we go 3 times the shortest side, that should get us our longest side. Oh, and s. I'm sorry, let's use z, not s. Okay, and then the second situation, the longest side is 17 inches more than 1/2 the sum of the other two sides. So that's actually kind of weird there. So that's going to be the longest side. So that's x equals, and then it's 17 inches more than 1/2 the sum. So the half the sum will be 1/2. And then I guess the other two, so we'll go as y plus z, actually. And then 17 more than that. So we'll say is 17 more. Yeah, so we'll do plus 17. Okay. and those will be your equations. Now, obviously, you can't, take this equation and type it out as a matrix right away, so we need to modify that a little bit here. Oh, and I guess I should have done it in blue. There might be a way to do that here. Style, there we go. Just so I have them color-coded here, you can follow easier. So we do need to distribute this 1/2, which is going to be kind of weird looking, but it'll be 1/2 y plus 1/2 z, okay, which means, oh yeah, and then plus 17. So typically we want all the variables on one side of an equation and then everything else on the other side. So we're actually going to subtract this 1/2 x over and the 1/2 z over. So it'll be x minus 1/2 y minus 1/2 z, and then equals 17. Okay, so that is one of the equations we're going to use. Now, the very first equation is in that x, y, and z order, so that's going to be ready to go. And then this red equation right here, we need to modify it just a little bit. We need that 3z to the other side, so I'm going to write it as x, and then minus 3z, and then equals, I guess, 0, since you don't have anything left over. And those would be your 3 matrix equations right there. And then now we're going to write out a matrix, or matrix, I guess, singular. So it'll be 1, 1, and 1 for the first equation. For the blue equation, we're going to go 1, 1/2, or actually negative 1/2, and then negative 1/2. And then that last one, notice here there's no y, so you got to put 1, 0, and then negative 3. Okay, and then after that, we'll put our variable matrix, so we'll go x, y, and z. Okay, and then that equals all of your constants here. So we'll go 83, 17, and then 0. Okay, and then I'll be switching back and forth here quite a bit today, so I'm going to move this screen right here, get it written down if you need. Oh, and that's a 1 out here in front. That looks terrible. Just notice that. Yeah, just so y'all can see it better. Come on. Okay, so let's start typing that into your graphing calculators. Move that away. Got a bunch of other stuff up here. So we'll go math, and then we'll go to, or not math, second matrix, and then edit. The first matrix is a 3x3, so that's good to go. So we go 1, 1, and 1. And the first one's 1. If you want to do negative half, I would just go negative 0.5. We'll just call that good. Negative 0.5 again. And then what do we got here? 1, 0, and then negative 3. Make sure you use the negative sign and not the minus sign. Okay, second mode to get out of there, second matrix to get back, and then edit, and then let's do the second matrix here, and that was 83, 17, and 0. 83, 17, 0. Okay, and then second mode. And then we need to type in A inverse B. I have it typed in from yesterday. If you hit second enter, you can retype it out again. But just in case you didn't watch that one, you hit second matrix, choose matrix A. You're going to go inverse, or raise a -1, and then second matrix, and then you're going to put matrix B. Scroll down, B. And hopefully we did that right. And that came out to apparently A is 39. B, or I guess not A, what is this? X is 39, Y is 31, and then the shortest side Z is 13. And then back up here, so yep, X was, so yeah, there it is, 39, Y was 31, and then Z is 13. That's how you find all the different side lengths there. Now, since they gave us units, probably good to write out the units there. So 31 inches, 39 inches, 31 inches, and then 13 inches. And that's about it right there. So, not too bad there. Setups are just, the setup's the important part there on these here. So let's see here, the yogurt shop. Not sure why there's an extra P in it either, but The yogurt shop sells cones in 3 sizes: small for 89 cents, mediums for 119, and then large for 139. Okay, one day Kyle Miller sold 52 cones. The number of medium cones sold was 2 more than twice the number of large cones. And then if he sold 58.98 in cones, how many of each size did he sell? Okay, so you do have 3 different variables, so we need to kind of, I guess, do all the situations here. So 52 total cones. I guess let's go S is the small cones. It's good to define your variables. I guess we'll go M is medium. And then I guess we'll go capital L for large. Come on. There we go. Okay, so if Kyle Miller sold 52 cones, we can say the number of smalls plus the number of mediums and then plus the number of larges should be 52. That's one of our equations. Now, once again, we have 3 variables, so we need 3 total equations to actually be able to solve this here. Let's look at the second situation. The number of medium cones sold was 2 more than twice the number of large cones there. So you can say your mediums, and let's color code it here. So mediums sold was 2 more than twice the number of large cones. So we can go 2L and then plus, 2 more. So if you take your larges, multiply by 2, and then add 2, that'll be your number of medium cones there. Okay, and then the last situation here, I guess, let's go purple here. Sold 58.98 in the cones right there. So I think going back to a couple of days ago here, that's a total. And what I said about totals, if you have a total, that means typically you're going to be adding a bunch of things to equal that total. Now, some people are going to want to put S plus M plus L, which is kind of close to what you need. But this is dealing with money right here, 58.98. So we need to attach our money values to the small, medium, and large cones. So I'm going to put my 0.89 out there in front of medium, 119 in front of, 89 in front of small. Was it 119, I think? Yeah, 119 in front of medium. And then the large was 139. Right there. That would be your third equation right there. So we are almost ready to go. Oh, let me try that again. Try to move it over here. Okay. First equation, you got all your variables together on one side and your constant on the other. The second one is not, so we're going to have to modify that. And then your third equation, it's got decimals, but it's ready to go because that's got it's got the S, M, and L all together. So let's take this blue equation, and all we got to do is just subtract over the 2L. And then if I'm going in the same order, we need mediums first. So we'll go mediums, and then I guess minus 2L, and then it equals 2. Okay, and we don't have any smalls. You can put 0S if you want. It's really not necessary. So that'll be your equation you're going to use there. So that one, purple, and red. Okay, and then let's get our matrix based off of that there. I'll go red equation first, I guess, since it's at the top. So that'd be 1, 1, and 1. Your purple equation here with dealing with the money. To kind of squeeze it in here. 89 cents, 119, and then 139. And then since we don't have any smalls for the blue equation, we're going to put 0. So we'll go 0, 1, and then negative 2. Okay, next is your variable matrix. I guess we're going small, medium, large. And that equals your constants, which I think the first, 52, 58, 98. If you can squeeze it in, and then 2 right there. Alright, and then it's just plugging into our calculator. So pause if you need to write it down. And we're going to go. So second matrix. Oh, it's kind of going slow here. Hopefully it doesn't crash. Second matrix. Edit. First one is a 3 by 3. It was 1, 1, and 1. All across the top. And then here we got 0.89. We got 1.19. Oh, and make sure you type it in right. All it takes is one number to be off to unfortunately derail all of the equations here. So next one was 0, 1, and -2. Okay. Second mode to back out. Second matrix to go back in. And we're going to go edit. Two, 58.98, and then the next one was regular 2. Okay, and then second mode, and then I'm just, instead of typing it again, I'm just going to hit second enter, and it'll retype that last thing. Oh, good, look at that, it came out real clean. Usually when it comes out clean, that probably means you're doing it right. If you start getting crazy decimals that look like not making sense, or like maybe like it's like a weird decimal for like something you should have a whole number of, that's usually when you want to go back and look. So we'll say the number of smalls is apparently 17, so 17 smalls. The mediums are 24, and then the larges were 11, and then that's it. Okay, so we'll get a couple more here, and we'll try and bust them out. The hardest part is setting it up. Once you know how to type it in the matrix, it's pretty easy. You got another triangle ABC. The measure of angle A is twice the measure of angle B. And then the measure of angle C exceeds 4 times the measure of angle B by 12 degrees. Find the measure of each angle. Okay, so they didn't tell us one thing here. You need to recall back in geometry. All angles inside of a triangle need to add up to 180 degrees total. So they didn't actually tell us that there. So we're going to say the measure of A plus the measure of B plus the measure of C is equal to 180 degrees. So that would be your first situation there. It's not really spelled out for you there. You just need to kind of use the logic and recall some geometry there. Okay, the measure of angle A is twice the measure of angle B right there. Be careful, a lot of people want to do 2A equals B, but it's angle A is the bigger, and to get angle A, you need to do 2 times B. So 2B equals A. Some people might write it as 1/2 A equals B. You could do that, but I like A equals 2B. So A is twice. Okay, and then the measure of angle C exceeds 4 times the measure of B by 12. Now it's kind of weird there. I need to kind of double check on this here. So 4 times the measure of angle B is just 4B, right? And then I guess C is the bigger angle. So once you figure out 4 times B, you need to add on the 12, I guess. And that's going to get us angle C right there. So I think that's your equation right there. Now, the first one is in standard forms, ready to go. It's got A, B, and C all together, and then your constant on the other side. For the second equation, we need to subtract 2b from both sides. So it's just going to look like this right here. I'm just going to write it to the side. It'll be a minus 2b, and then you don't have a c, and then equals 0. And then this second one here, we need to subtract over our 4b. But actually, if you get the order correct, you need to put 4b first. So it's going to be negative 4b, and then I guess plus c equals 12. Right there. And these are your 3 different equations that we're going to use for our matrix. And we'll go and set that up. The first one is, I guess we're going to do 1, 1, 1 across the board. For a minus 2b, that's 1a minus 2b and no c's. And then the third and final equation, 0 a's, negative 4b, and then 1c. And then I guess a, b, c, that matrix, and then 180, 0, and 12. I'm going to go type those in. I can enter to retype the previous thing. And that came out. Okay, so we worked it out here. We got A was 48, angle B, and I guess this is in degrees here, so 48 degrees, 24 degrees, and then C was 108 degrees. And then that is all you do there. That there. Okay, cool. All right, I think 2 more, and then we're done. So you got a carry-out pizza restaurant. An order of 3 slices of pizza, 4 breadsticks, and 2 soft drinks are $13.35 here. So you got 3 variables here. So let's say P for pizza, I guess. Number of, or wait, what are we trying to find here? Second. So yeah, go look at what you're actually trying to find here. It's what's the cost of each item. So we need to say, instead of P the number of pizzas, we need to say P is the cost of pizza. And then B, we'll use B. I'll use capitals so we don't get confused here. Cost of breadsticks. And then, so I've used an S. That kind of looks like a 5, so I'll use like a, I guess I'll use a D here for cost of drinks. There we go. So this one's pretty straightforward here. You got 3 pizzas, so I'm going to put 3P plus 4 breadsticks, and then plus 2 drinks. Or I guess lowercase there's apparently $13.35. Okay, second order, so 5 pizza slices, 2 breadsticks, and 3 drinks is equal to $19.50. And then if 4 breadsticks and a can of soda costs 30 cents more than a slice of pizza, what is the cost? Okay, so then this last one here is kind of a special one here. 4 breadsticks, so I guess I'll go 4B, plus a can of soda, which is, I guess, 1D cost. So that's 30 more cents than a slice of pizza. So I need to take the pizza cost, I need to add on 0.3 or 0.30 right there. And then that will be the cost of the 4 breadsticks and the drinks there. Okay, and so those are your 3 equations. Obviously, these first 2 are ready to go as far as typing it into your matrix. But the last one here, we need to move that P to the other side. So we'll go minus P. So I'm going to write that, I guess it's negative P. I guess I'm going to go in the same order, so plus 4 breadsticks, and then plus the 1 drink. And then apparently that equals 0.30. So that'll be your third equation that you'll use. All right, let's set it up as a matrix. So we'll go 3, 4, 2. We'll go 5, 2, 3. And then negative 1, 4, and then 1. All right, go in the same order as your variables here. So I got pizzas first, breadsticks second, and then drinks last. And then $13.35, $19.50, and then 30 cents. And then get that written down. Pause if you need. Skip ahead if you don't want to watch me type this in. Whoops. Alright, and then second, enter. Alright. So we got $2.95, 50 cents, 50, and then $1.25 right there. Oh, this is struggling here. There we go. Okay. And let me scoot it over so I can see. Okay, so slice of pizza was $2.95. Guess I'm going to put my dollar symbol out there front. Breadsticks were 50 cents each. And then your 1 drink was $1.25. There, and those are your costs. And decimals make sense for this situation here. So that's always good when that happens. So, yeah. And then last one here. What do we got? A whole nut. Oh yeah, put a star next to this one. I know this always throws people off here. So you have a nut wholesaler sells a mix of peanuts and cashews. The wholesaler charges $2.80 per pound for peanuts and then $5.30 per pound of cashews. The mix is to sell for $3.80 per pound. How many pounds of peanuts and how many pounds of cashews would be used to make 100 pounds of the mix right there? So we don't know how many pounds we need total. So let me zoom in here. So we're going to say P is the number of pounds of peanuts, and then, or I need an A there, whatever. So peanuts, and then I guess we'll say C is the number of pounds of cashews. Okay, so you need 100 pounds total. So we can say P plus C equals the 100 pounds total here. And then the next one here, we're going to attach our money values here. So what do you have? 280 for peanuts. So I'm going to do 2.8 P plus 5.3 C. But then a lot of people want to put that last price value, but notice that's the price per pound right there. So a lot of people put just $3.30 right there, and that's not the total cost there. The total cost is $3.30 actually times the 100 total pounds that you're going to get. So that'll, slightly change that number right there. So actually our real equation that we're going to use for our matrix is going to be 330, I guess, dollars there. Right there. So this will be your equation, and then this will be the other equation. Okay, so this one actually, it's only two variables here, which is kind of nice. It'll be a 2 by 2 matrix then. So it'll be 1, 1, 2.80, and then 5.30. What do we have here? P and C, and then equals, what do we have here? I guess 100 and 330. Okay, and then we'll type that in. Second mode, second enter. Alright, excellent. So we got P is equal to 80 pounds. Oh, whoops, P, no. And C was 20 pounds of cashews. And that is your answer there. I believe that is the end of the long unit. Here we go.